So, good afternoon, everyone. Thank you for coming. I know that it is one of the last slots at the conference, so it is not so easy for all of us after nearly 2 days. My name is Mihail Mateev, and I'm from Bulgaria. I work as solution architect last several years almost only on Internet of Things solutions. So that is the reason actually to have motivation to prepare a session which is related to IoT, but it includes also AI components, predictive analysis, something which is more from the applied side. Before to start, I have a question. How many of you work on Internet of Things solutions? Not so many. How many of you work on artificial intelligence? Not so many. So probably I have no need to ask about machine learning because machine learning is part of artificial intelligence. But also, how many considered what is the case related to predictive analysis? I will try to explain. So please interact with me and ask me in any moment if you want more details or if something is quite clear for you. Because in this way, probably it will be more useful for you. Initially, I will skip this slide where I added a few things about me because I already represent myself. But initially, the idea was to explain some things related to the common case because it is important if we are not 100% in the context to go first to this part. After that, to see what we have related to predictive analysis. Probably we will add some things what we have on Internet of Things if it will be useful for you. And after that, we will have some examples how to integrate artificial intelligence, particularly machine learning, but also cognitive services in Internet of Things solutions for predictive analysis and not only. But predictive analysis will be more essential in the context of use case, which we cover. Regarding to the technology, it is quite similar to all AI-related cases which we have in Internet of Things. So, probably it's good to start with what is the case. You know that many companies now trying to stay high-tech companies, but these companies come from other areas, industrial areas, some other parts of business. And in this case, we need to have parts which are related to optimization of the flows which these companies have. And regarding to this, we have many different components, but one of the most important is Internet of Things. And regarding to Internet of Things, we again considering optimizations to have more optimal solutions. What you know about Internet of Things? Did you read something? Did you see some things? Okay. I will try to ask some not very difficult questions and will give prices. Prices are Azure subscriptions. Probably it will be useful for you if you want to spend additional time and to try something in Azure. Probably some of you already have MSDN subscription or subscriptions related to your work, but in any case, I think that it will be useful. So we have need to connect different devices to backend services which do some analysis. This is the high-level concept when we have Internet of Things. And in this case, we have different use cases which we need to solve. We need to have remote monitoring. That means we have different machines, a lot of devices. These machines can be from very simple coffee machines to very complex aircrafts, ships, cars, whatever. And we need to have option to make tracking how these devices work. So this is probably one of the simplest cases which we have here. We can make configuration remotely for these devices. That means we can make some changes of configurations without need somebody to go on site, which is very important and let us to have more optimized business with less expenses for maintenance. What else we have actually? We can have predictive analysis, which means we can, based on this information, to include some artificial intelligence components to have prediction in our solutions which components will need some maintenance, and we can change these components or repair these components predictive in advance to be possible to have no losses because of stop of some work processes and to have no need to spend additional time to find where is the problem if something happens. So if we have for industrial companies Internet of Things, probably the biggest added value is exactly related to predictive analysis. That is the reason to start this session related to exactly this topic. Before to continue, I will give you examples from different areas, but probably it's better to ask because you need to have Azure passes, as I mentioned. So, can you give some examples in which areas we need, not we need, but we can use quite effective these predictive analysis, like business areas? Question is not related to knowledge of IoT and knowledge of artificial intelligence. Can you repeat? Yes, factories and production. This is one of the areas. We name it industrial automation. Another guess? What you think about vehicles? Automotive industry. So, for automotive industry, we have a lot of devices. When we see new vehicles, they have several IoT systems, not only one, controlling different subsystems. And they have critical emergency systems which control engine brakes, etc., and many additional which control not so critical solutions. But all these systems are more or less related to this. What about construction? Any guesses? Do you think that we can use it? Many structures actually are quite high-tech, like solutions because we have bridges, dams, skyscrapers, trade centers with a lot of sensors. And these sensors give us opportunity to monitor the whole state of these structures. For example, New York bridges are one good example about this. You have predictive maintenance there because they know based on information from sensors about displacement of specific points of elements that these elements probably need to be replaced or repaired, for example. So that's the reason to have so many different industries. One of important areas is energy. Smart energy use a lot such kind of solutions because we need to optimize energy consumption, and it is possible to do it with Internet of Things. I can talk probably a lot about this, but our session is a little bit more focused on predictive analysis. So we will continue forward. I just added several slides about first, how to put it, solutions when we have such kind of monitoring. But this is usually just a small part of IoT. When we have monitoring, we need to make some smarter, to have automated logic, to have prediction for some things. So in this case, there are different technical solutions related to different software vendors, but Microsoft offers probably one of the most completed stacks related to Internet of Things, including artificial intelligence, which match very good for predictive maintenance. How many of you work with Microsoft Azure? Good. That's good. How many of you know what is edge computing? Edge computing, and in the context of applied areas, we will talk about IoT edge and AI edge, is approach where we have multi-layered solution, solution, where we have the main analysis at the back end, but on site we have also computing which do part of analysis. Why we need to do that? Okay. Till this moment, most of data over the world is on site. I mean that worldwide there is a lot of data produced, but most of data is still on site. And it is because of different reasons. Because it is sometimes not so effective to move everything on the back end and to turn it back. Also, if we have only analysis on the back end, what is the major problem? So we have several problems. You explain few of them. So you will have additional Azure Pass. You can decide to get it or to give it to another friend of you. But from one side, we have not consistent connectivity because it is possible time to time to have not so good connection or even to have no connection. So this is one of the problems. Another problem is that we need sometimes to have very small response time. If we need to have very small response time, we have for now physical limitations. Imagine that you have production line and you need to have for this production line such kind of monitoring of losses and analysis what you need to do if you have some problems. If we do this and on the back end only and transfer all this information, that means you are not able on the production line to have immediately response and to have reaction. It is the same with vehicles, with cars, aircraft and some other machines. Sometimes we need very small response. Third part is related to financial consideration because quite often we need on site some not so difficult calculations which we can do, but if we transfer all this data from millions and billions devices to the backend and get a response back, it is actually sometimes not so optimal. We have a lot of additional transfer which costs money and in general brings even additional risk because as more functionality you have, as more options something to fail you have. So in this case, we really need to have something on site, something on the edge. And regarding to this, Microsoft offer so named IoT Edge. We will talk about IoT Edge in the context of AI Edge also, a few minutes ago. Do you know what is IoT Hub? Some of you? Okay. I have, but not in this presentation, quite a detailed overview of major components of IoT. I have here also schema, but a little bit later. But usually when we have Internet of Things, we need to have one service which is responsible for connectivity between devices and backend. And this service is Azure IoT Hub. Do you know some other services which can be used for this? It is possible to be not from Microsoft. Event Hub is possible to be used. You will receive also one more subscription and you will decide if you will share it with some of your friends. But what is the difference? If you have Event Hub is essentially messaging broker. If we have messaging broker, we can make our solution in a way when both sides actually subscribed to some events and we can have communication in this way. But we have security issues there, and that's the reason to have more complex models like IoT Hub. Unfortunately, detailed internal schema of IoT Hub is not predicted for this presentation, but in IoT Hub you have two queues. One queue which is for collecting of information from devices and another from backend services. And each of parts writes to one queue and reads from another queue, which means they do not communicate directly. And this brings quite good additional security because the only one component in the whole system which accepts inbound connection is IoT Hub. There are other services, of course, which can be used. What about open source services? You can use also some service. Any suggestions? I think that it is already possible, but not directly. I mean that you need to have connectors, so your devices need somehow to send this data to some place from where you need to get this data. So Power BI is main component for many IoT solutions, but to get data directly from devices technically is possible. Practically is quite difficult because you need to have for different devices different connection strings. In general, it will work only for experiment that it is possible. Yes, but in any case, I will give you also subscription. I know that good approach to have uh, things to work better is to try to experiment. So this is something good. I will not go deep in this schema. It is just to show you that you have edge computing and that you have different layers on the backend. And you have communication preferably via IoT Hub. It is possible to have several different connections, but it is not good from the context of design. I apologize if I give some more impact on these parts, but usually the major problems in solutions comes not because something is not implemented on development side very well. Problems are because it is not considered on the architecture level. So, what about everything which we have on the edge? We have framework offered from Microsoft, which is named IoT Edge. How it works? Actually, we have containers which work on devices. It is common approach for everything which will be in the near future for all software companies working on Internet of Things solutions. All components which we need in these solutions will be deployed in containers and they will have part on the devices and part on the backend. Regarding to this, we have the same situation when we have IoT Edge. IoT Edge is not 100% pure edge in the context of edge computing. What I mean? In IoT Edge, framework is implemented in a smarter way, and this framework do whatever is possible on site, but part of functionalities can be done on the backend. So IoT Edge needs internet connection. If it is not connected for a long time, it is still a problem. Probably in the future, it will be not a problem. But in the moment, we need to expect connectivity to be relative stable if we work with IoT Edge. What about AI Edge? AI Edge actually for now is related to framework, which is on the top of IoT Edge. So we have additional packages and containers which are deployed on devices and they have some functionalities. Can you give me proposal what related to artificial intelligence we can have on devices? Okay, this is one of the things which work because quite often in such kind of systems it is possible to use your voice to let solutions to make some activities. For example, to open the door or to make something different. So speech recognition, image analysis. There are good examples, even you can see information about some startups which use, for example, drones for image recognition and they do some analysis on site, that means on the devices in a drone, before to send information to the backend, because otherwise it will be a huge traffic. And this is the major initial concept. What we have additionally, I will skip this diagram. So, if we have um, solutions where we have IoT Edge, many components are implemented also on the edge. What is the benefit? That you have the same looking SDK, and in this way you are able actually to implement in the same way functionalities which are on the edge and on the backend. So excluding the major goal to have, because of technical reasons and financial reasons, computing on the edge, we have also things related to productivity for solution development, to make it simpler, faster, in the common way. And we have, in general, this concept. So we have communication via gateway. Gateway is general name of the IoT Hub, and we have different models which can be used on the back end, and the same or almost the same models on the front end. I will skip few things. Even I will continue with this. One of the major how to put it, abstractions here is model. What is model? Model is usually independent group of functionalities which can be deployed in separate container. So regarding to IoT Edge and AI Edge, this is the way how it is implemented, and it is the way how we can extend this. This is one of the most important. When we have similar functionalities, IoT solutions and in general solutions stay similar for deployment of application model like mobile devices. You have new application and you deploy container on devices, and you deploy container with some additional logic on the backend. So things are going in the same direction. Just we have usually two different components, of course. Let's see how we can make in the whole solution connection between other components and machine learning and other artificial intelligence parts. Because you will see many schemas which are quite complex. So you have, in general, some arrows which show some layers, but not so detailed things. Oop. If we have in the consideration, in general, AI functionalities, in the context of AI and also Microsoft AI, we have three groups of services. Cognitive services, which represent what? Do you have opinion about what we have as cognitive services? It is, but not only. I will give you for the suggestion, but it is not only this. Usually, we need to have simplified approach to use machine learning and subsystems of machine learning, but to not know a lot about the details. And cognitive services, for some more general tasks, offer us API which is possible to be used without even small knowledge about machine learning. So we can start to use AI in this way, and cognitive services in the context, for example, of Microsoft Cognitive Services offers very wide area of functionalities, image recognition, text recognition. I think that voice recognition is also available and several other things. So more general things which you can use via simple API without to have idea how it works behind the stage. And we have machine learning, of course, which can be used on the deeper level, and bot services. Bot services are also part of from this solution. Do you think that we can use bot services in IoT? It is not straightforward. It could be, but it is not straightforward. We can mostly use other two parts, so machine learning and as simplified approach, cognitive services. I'm not sure if this schema is big enough, but I can try to explain. Usually, when we have such kind of solutions, we have data processing, which is from the backend one of the common parts of IoT solutions. When we have data processing, usually we have two channels. Hot channel, where we process data close to the real time, and cold channel, where we collect data which will be analyzed in different timeline. We have these components which are very important for the common concept, how we will manage predictive analysis and in general AI here, because you see a little bit different components. So, how to integrate machine learning? It is again the same with cognitive services with the rest of the thing. First, we need to have data. We need to have data, and we need to have at least examples which we will use to train our model. Without these, it is not possible actually to have the common flow. I'm not sure what is your experience. Did you ever read or see how in solutions on stages, in which stage is implemented any kind of artificial intelligence, predictive maintenance or whatever? Usually, usually we have a solution where we need to collect data, we need to ingest data, and after that we start to implement other models, because otherwise this machine learning without data will be not very useful. This machine learning can be represented in Microsoft Azure, of course, in several different ways. We will talk probably a little bit later, but if we use the simplest one, which is the simplest one? Yes, but to go to web service, what we need to do in advance? Okay, create a project in Azure Machine Learning. So the simplest way to integrate your solutions is if you start with Azure Machine Learning Studio and you publish API which will be in web app. So you can do this without any deep knowledge about some APIs integration. It is just done by default after you have the model, of course. And if we have this, we need somehow to integrate this API with other models. Do you have any suggestions what we can to use? Well, we have web service with REST API. How many of you have developer background? Okay. So what we do to get some functionalities from web service. We can have quite simple calls from custom logic. It is one of the things. And second is if we have specific integrated out of the box logic in some services. But using code, it is quite straightforward. We can use out of the box Azure Stream Analytics. I suppose that you have some experience with Azure Stream Analytics, correct? Okay, so Azure Stream Analytics is one of the major components, not mandatory, because we can process data in very different way. But it is simple, not expensive, and Azure Stream Analytics has these functionalities without specific knowledge to get whatever we need from published Azure Machine Learning API. So this is something which gives us option to have this integration quite simple. That's the reason in most of the schemas to have something similar. Not because it is the only way, just because it is easy. I just added few screenshots. If you have Azure Stream Analytics, you can add Azure Machine Learning function. In an Azure Machine Learning function, you need to choose the name of the function and to add endpoint. Endpoint you already have when you published Machine Learning API. And if you have this, for example, you need to have some simple code. For example, it can be very complex, but let's say that we have here some simple example. We have sentiment one, for example, like function, and we call this function, and after that, from the result, we get properties which we need. Collections or simple properties, but what we need. So you can have almost without code in this simplest approach integration with Azure Machine Learning. What we do if we have a call, if we have code? Of course, it depends on the framework, but I just give very high level, very high level snippet where I added HTTP client, and you are able, in a way, like you can call any other service to call functions and to get results. So that means integration is not difficult, it is quite reasonable. There are a lot of different examples. We will see one of the examples which are from, how to put it, relative standardized solutions. You can see from different components to have such kind of calls. But usually, in this case, you have custom implementation using calls against Azure Machine Learning API. For example, if you have some services where you collect information from Event Hub or whatever, it is not possible for many services directly to consume Azure Machine Learning API. For some, like Stream Analytics, that is a specific case. Usually we have custom implementation. That is the reason to pay attention about this. I will demonstrate one example which is relative standardized, and it is based on this design. We have, well, it is with simulator to be possible to be demonstrated without real devices. It is not difficult to change this part, but we have some data. This data is processed, and why we need to have event hubs do we need to have in general messaging services? It is not mandatory. We often use messaging services because of several reasons. Because we can have implementation of eventual consistency for our system where we can have distributed system like it's usually in the cloud, and we have messages from some subsystems which will be actually used from other subsystems, but it is not needed to have everything in, how to put it, solid transaction. So if we have something like this, we can have distribution via event hubs, and after that, because event hub is not able directly to use machine learning, we have in the client which listen, which is some web service, this implementation. Let's go a little bit ahead. We can have logically related to artificial intelligence services in all these contexts, machine learning and cognitive services, calls from different parts of our solution, depending on whatever we need. So stream processing is one of the most reasonable when we need to have real-time response which is based on specific already generated experiment, for example. When we talk about real-time processing, it is close to the real-time. It is not 100% real-time. And when we talk about machine learning and AI, it is not real-time analysis. It is what? Real-time it is analysis. Probably I didn't explain it in a proper way, but mostly specific type of real-time prediction. That means we need to have in advance this trained model, and we need to we can have such kind of predictions. This is the most important. Of course, there are options which often are used this model to be better and better because we have more and more data and it is trained meanwhile. But we have mostly prediction. If we have integration with other components which are mostly related to reporting and monitoring and whatever, we can have all components, not all components, all possible analysis, but in real time we consider mostly prediction. All these components which I mentioned are related to our analysis. So we have need to consume this data. We need to okay, thank you. We need to call service for predictive analysis, and after that we need to store somewhere results or to send some messages. I will not talk about Azure Machine Learning Studio. Just here, regarding to whatever I show, I will show example now with demo. We can do it quite interactively for those of you who didn't use it till this moment. When we have components in this example, usually it's good to know that, for example, in Internet of Things, we have several major parts which need to be considered. Internet of Things solutions collect data. If they collect data, they need to persist data in scalable, cheap storage. This is usually storage considered for the code path. When we have processing, usually we have different outputs. For this code path, we have information which is not processed, eventually it can be enriched. Enrichment means to have metadata which you can add to your messages to have better for analysis data collected in our storage. If we have if we have hot channel, that means close to real-time analysis, we usually consider several options depending on what specific requirements. If we need to have relative huge amount of data, again, it needs to be scalable, and solutions like Cosmos DB or different document-based solutions are quite good. If this processed data is relatively small, it could be even considered relational database. But if it is not, in IoT solutions, we usually think in the context of relational databases mostly about configuration data, which is for settings, and such kind of metadata for enrichment. Most of other parts usually are different kind of SQL. We can have for different logic on the back custom implementation with microservices, of course, where we can call machine learning in the way which we discuss, or if we have, as I mentioned, stream processing, and it will be out of the box. Cosmos DB is also quite often used not because it is scalable, but Cosmos DB has quite a good API related to event-driven design. And you can subscribe for some events and to call, for example, Azure functions, or to do it in a different way, and to have on-demand such kind of functionalities. In general, probably some of you tried in the past. Do you have experience with Cosmos DB? What is your impression? Do you think that it is cheap or it is expensive? Most of people consider that it is expensive with default settings, but it needs to be tuned. If it is optimized, you can decrease 10, 20, even more times actually the price. So there are slightly specific details. And other elements we already discussed: IoT Hub, Stream Analytics, web job, which is actually scheduled task in web API. Let's go ahead with the last part, cognitive services. We already discussed about cognitive services. We discussed that we have several group of functionalities related to analysis: phrase extraction, language detection, sentiment analysis, language understanding, image recognition. Excluding even all of this, I started initially to say excluding probably the first, but even we need sometimes first. There are many devices where you can use this. So in general, we will be able to use all these functionalities. At least till recent releases for cognitive services, at least for the previous month, image recognition is needed to use Azure. In general, as I already explained, AI Edge is not possible to work completely decoupled, but it is planned, so probably in the near future we will have such kind of implementation. So for image recognition, this implementation will be done on the back end. And we have absolutely similar situation, but instead to have direct call to Azure Machine Learning API, you have call against Cognitive Services API. So usually you can have a similar solution where you initiate based on specific logic calls to cognitive services. You can have, for example, quite often data flow solutions where you can have on specific stages calls to your AI services. Here I added TensorFlow just to show that it is not 100% needed to use, for example, something which is from Microsoft Azure Stack, like Logic Apps, but it is more expected to put probably this service. So you can have very often solutions where you generate, because of specific events, some calls. These calls goes for some data flow engine, and from this data flow engine you have separate communication with AI services. It was implemented also in a little bit more complex way. Here is with Logic Apps, but it is with Logic Apps and we have cognitive services in a similar way. When we have AI edge devices, I just added in the end deployment model, what I already explained. We have on the higher level this kind of solution. You need to have IoT Edge runtime and AI modules which are in containers, container registry, or another repository from where this is used. And we have a relative simple way to automate these functionalities to start automatically to work. If we have edge devices, the example with drones, which I explained, is something like this. This is real use case. What is the challenge? Challenge is to have proper data model. To have proper data model is not the context of this presentation. You need just to have a model which will give you with high probability whatever we expect for prediction. And usually for cases when we are not able to use already offered algorithms, we need to have deeper knowledge on statistics. And the last thing is that we need to have good knowledge about business domain, because this model is quite related to specific business model. It is not part of our presentation, but it is something which is probably the major challenge. Whatever I explain, like integration, it is something which will be not difficult for most of you to be considered and implemented. And at the end, for a few minutes, we will have short demo. This demo is related to predictive analysis. I already deployed this demo in Azure, but it is modification of so-named IoT solution accelerators. If you have time to see major types of IoT solutions, you can see in IoT solution accelerators such kind of applications like proof of concept, which can give you overview how you can have the major components and parameters for different IoT solutions covering the major use cases. And if you have, for example, specific solution, you can go and to look at the documentation. What we have in the deployed model? In the deployed model, we have, let's go here and try to zoom it probably. I deployed in a separate resource group all components to be more clear. So we have, let's do it in this way. We have stream analytics, the green icon. We have also, because of some event-driven components, usage of Azure functions, we have IoT Hub. We have different storages because we need to store somewhere data, and we have several more components. Let's just show. So we have Azure Machine Learning, but this Azure Machine Learning actually use the same approach which I explained, and we have two different web apps, one which is consumer and with UI, and another one which expose Azure Machine Learning API. So if I go to the first one, I suppose that my token expired, and that's the reason to ask me again for this. We can go to this endpoint. Which should work. Let's try to do it in another browser. Yes. So it is a relatively simple web app where we have representation of whatever is received from simulated device. This simulated device sends via IoT Hub and Event Hub to a web app which is client of Event Hub information. This web app calls Azure Machine Learning API and actually provide this analysis. It is relatively simple. The idea is that if we keep it a little bit longer, we will see, based on simulated data, that we will receive information how many cycles we will have more with which of engines. In general, there are used two algorithms. They have regression algorithm and they have also classification algorithm which is used, but my idea is mostly to see how you can use predictive maintenance. Usually it is one of the parts. Based on whatever you see here, you can have automated triggering of some functionalities which can make something to send notification to devices or to specific people or to another system. That specific device need to be considered and treated in a specific way. So this is the most important related to this presentation. Thank you for attention. Hope that some of things were interesting for you. If you have any questions related to IoT and any kind of related to IoT functionalities like predictive maintenance or something else, I will be glad to contact me, because I will be glad to share my experience, good or not so good, because the real life is not in pink color, but I will be glad to be helpful. So thanks again.